Welcome back to section 4 of chapter 7. In this section, we're going to begin looking at factoring polynomials. Now, factoring is like reverse multiplication. It's not quite division, but it actually leads us towards dividing polynomials. But we're just going backwards to see what times what would have gotten us this. Today, we're going to be working on factoring the greatest common factor out of a polynomial. So, our learning targets for today, I can factor a polynomial, specifically the greatest common factor. So, what is the greatest common factor? The greatest common factor is the largest thing that can be divided into each of the terms or each of the numbers. We found greatest common factors of numbers in the past. So like, what is the greatest common factor of 12, 8, and 6? To find this, we would factor each of these. So we have 12, we have 8, we have 6. We can make factor trees. 12 is going to be 4 times 3. 4 is 2 times 2. So we have 2 times 2 times 3. 8 is 4 times 2, and 4 was 2 times 2, so we have 2 times 2 times 2. And 6 is 2 times 3, which is just 2 times 3. And so, for greatest common factor, we see what do these have in common? They all have a 2 in common. Now, they don't all have another 2, and they don't all have a 3. So here, the greatest common factor between 12, 8, and 6 is 2. All right, well, that's with numbers. What about with a polynomial? So we would do the same thing. We'd factor each of these. Now we could multiply, or we could like write them multiplied out. So notice we have 12, 8, and 6 again. So we know that 12 was 2 times 2 times 3, and then we have x to the fifth, which is x times x times x times x times x, plus we have 8 to the fourth. 8 was 2 times 2 times 2, and then x to the fourth is x times x times x times x, and minus 6 cubed. 6 was 2 times 3, and x cubed is x times x times x. So what do they have in common? Well, they had that 2 that we saw earlier, and then they have x's. They have one x here, well then they have another x, and then they have another x, all in common. And so here, so they had the 2, and they had 3 x's, so that would be x cubed. Now, a shorter way of doing this, so that you don't actually have to draw them all out, is, notice the cubed, that's just the lowest of the exponents. So you don't have to draw them out. It'll be whatever the lowest exponent value is on it. So we factor the numbers to get the greatest common factor of each of the numbers, and then we take the lowest exponent from the variable. So let's try a couple. We have 15x squared plus 18. Notice that 18 does not have any x's, so they have no x's in common. And we have negative 18y to the fourth plus 6y cubed plus 24y squared. So try each of these. Pause me for a minute so you can try them, and then when you're ready, come on back. All right, let's take a look. So the 15 is 3 times 5. The 18 is 3 times 6, and the 6 is 2 times 3. But when we had 3 times 5 and 3 times 6, I mean, the only thing in common there is going to be the 3. And then they have no x's in common, so the greatest common factor here is just 3. Over here, we have 18, which is 6 times 3, Notice we don't care about the negative right now. 6 is 6 times 1. 24 is 6 times 4. Notice how they all have 6. 6 is going to be the greatest common factor here. Let's say you didn't notice that. I'm going to keep going so we can see what happens. 6 is 2 times 3. This 6 was 2 times 3. This 6 was 2 times 3. And so they all have a 2 in common. They all have a 3 in common. And so our greatest common factor, we have 2 times 3, which is 6. And then we have some y's. What's the lowest exponent on the y's? That would be a squared. So we have 6y squared is our greatest common factor of this polynomial. So how are we going to use that? We're going to factor that out of the polynomial. So if we have one here, we have negative 12x cubed plus 18x squared minus 27x. We're going to find the greatest common factor. So 12 was 4 times 3, and 4 is 2 times 2. 18 was 6 times 3, and 6 was 2 times 3. You might say, well, what if I went 9 times 2? That's great. 9 is 3 times 3. You will end up with the exact same factor. 27 is 9 times 3, and 9 is 3 times 3. So what do these have in common? They don't have a 2, but they all do have a 3 in common. And then that's all that they have in common. So it's 3, and then we have an x. And there's only one x because that was our lowest variable. So we're going to factor that out. That is going to come out here. Now, what would we have to multiply to get these values? So 3x times what equals 12x, negative 12x cubed? Well, 3 times what equals negative 12? That's negative 4. And then how many more x's do we need? We need an x squared, because x times x squared gives us that x cubed. Plus 3 times what equals 18? That would be 6. And then to get to x squared, we have 1x, we need another x. And then minus 3 times what equals 27? I already have the negative there. And that would be 3 times 9 equals 27. We don't need any more x's. So we're there. Another way of getting those numbers, if you have your factor tree, that 4 was 2 times 2. That 6 was 2 times 3, and that 9 was 3 times 3. It's the leftover factors. If you expanded out your x's as well, so we had for the 12x cubed, if we had 2 times 2 times 3 times x times x times x, and we pulled an x out, it would be those x's that were left over. So let's take a look at the two that we just did. We found the greatest common factor of this first one was just 3. So when we factor out a 3, we have 3 times, well, 3 times what equals 15? 5. And then we need both x squareds, plus then 3 times what equals 18? 6. Notice something inside the parentheses will not have an x in it, because if everything has an x, that means you could have factored that x out. So there will be a constant in there. Over here, our greatest common factor was 6y squared. So we'll start out with 6y squared. And then times what equals negative 18y to the 4th? Well, 6 times 3 equals 18, so it needs to be negative. So we have negative 3. And then y squared to y to the 4th, we need 2 more. And then 6 times, well, 1 equals 6, so we don't need a number. Y squared to y cubed, so we need a y. Could be plus 1y. And then 6 times what equals 24? That would be 4. And y squared to y squared? Nope, we have that. So that would be factoring out that 6y squared. So let's try a couple more. Go ahead and try these ones. Pause me, come back when you're ready, and we'll see how you did. All right, let's take a look. So in this first one, the greatest common factor between the numbers is just going to be 1 because that's a 1. Like, we can't go lower than that. So how many x's do we need? Well, they all have at least one x. So we're going to take out an x. Well, x times what equals x cubed? That's x squared. Plus, we need the 5. And then how many more x's? Well, to get from x to x squared, we need that 1 more x. And then when we take out the x from this one, we just have minus 22. Now, if we multiplied this through, we would get right back to where we started. Over on the second one, factoring out our greatest common factor, our greatest common factor here would be 4, because 16 is 4 times 4, 28 is 4 times 7, and 20 is 4 times 5. So we'll have a 4, and then how many y's? The smallest exponent is that squared. So we'll have y squared. All right, so 4 times what equals 16? Well, 4 times 4 equals 16, so we'll need negative 4, so it's negative, and then y squared is already there. 4 times what equals 28? Well, that's a 7, so plus 7. Y, let's see, we need to get to y to the 4th. We have 2, so we need 2 more. And then minus 4 times what equals 20? That's the 5. So we have 5, we have y squared, we need y cubed, so that's an extra y. We could write this in standard form if we wanted to, especially if it was asking for it, which would be 7y squared minus 5y minus 4. So that's factoring out the greatest common factor, and this, we're going to build off of this significantly in the next couple sections, because we'll be factoring where it's more than just pulling out that greatest common factor. But the very first step of factoring any polynomial is to factor out what they have in common, which is that greatest common factor. If we wanted to look at kind of like what this is, like in a visual way, we could have these 6 photos, and Alani is in charge of marketing for a travel company. She's designing a brochure that'll have 6 photos, and the photos can be arranged on the page in a bunch of ways. So we have 2 main square photos, which have lengths x on each side. So this is going to be x by x and x by x. And the 4 narrow photos that are 1 inch by x, so it'll be 1 and x. So the very first question is, what's the total area? Well, we have the big photos. The area is going to be x times x, which is x squared. And there's 2 of those. Plus, we have the little photos, which is going to be 1 times x, which is just x, and there's 4 of those. So we'll have 4x. So now we could factor out a greatest common factor here, but we could also factor out different things. So the question here is, how could they factor? We have this picture right here. So if we looked at this picture, the height here is x, because that's the big picture, and then we have x, x, and then that's 1, 1, 1, and 1. So this would be 2x plus 4. X times 2x plus 4. Notice how if we multiplied this, we'd have 2x squared plus 4x, which is that total area. And so that's how that factored. Was that the greatest common factor? No, 2x and 4, you can still divide both of them by 2. But that could be your brochure. It depends on what the size is. Is it one that's one of those long ones that you unfold? In that case, this would work out. It could also be like this. In this case, we have this one's x, this one's x, this one's x, 1, and 1. So in this case, we have 2x times x plus 2. If we multiply here, we'd have 2x squared plus 4x, which is, notice, the same area. Also notice that this one and this first one actually have the same area, just because we rearranged a couple of them, like we reversed the order in the bottom one. It didn't actually change the area here. But this one factors out the greatest common factor. Now, if your brochure is like one page, like it's just like a sheet of paper, this looks a lot more like a sheet of paper. Like it's got that, it's not too long and skinny. But this, notice we had this total area and we factored stuff out to get the side lengths of these rectangles. That's kind of what factoring is doing. It's that backwards multiplication. So this is what we're doing this section. Again, the next couple sections, we're going to be expanding on this topic quite a bit. But we will get there next time. So I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.